start again. Okay, so let's move on to the next concept in stoichiometry, that is percentage purity. So percentage purity indicates how much of a substance in a sample is the desired compound, right? So for example, if you are reacting, if for example, let's just assume an example, right? So if you're reacting uh, compound A with compound B, right? And for example, you're getting C and D, right? So, for example, the solute, for example, let's say okay, B is the solute, okay, and A is the solid that you just put in to the solute, okay. You dropped a piece of A into B, okay. B is a liquid, so yeah, and then you allowed them to react, okay. Ab, जब A react करेगा B के साथ, and A will react with B, so this will produce C and D, right? But what if this solute has some impurities? Okay, it's not 100% pure B. Okay, so it will this A, some of this A may react, may react with the impurities in B and will form some additional, I'll just write them in blue. Okay, it may form some additional compounds that we know not of. Okay, those are the impurities, right? So it may form impurity I and J. Okay, but I and J will also contribute to the mass of the final product. है कि नहीं ऐसा? अभी तक समझ आ रहे?
जी.
Okay. So A may react with some impurities in B to form I and J. That these are impurities, okay? And C and D are your pure products that should form. But the impurities are contributing to the final product, right? So you need to calculate the percentage purity, right? Now, if there are impurities in B, so the final mass, would it be greater than the theoretical mass or would it be lesser, Rafi?
Lesser.
No, greater, क्योंकि आप इम्प्योरिटी से रिएक्ट किए, ए ने इम्प्योरिटी से भी रिएक्ट किया है और बी से भी रिएक्ट किए, तो इट शुड बी लाइक ग्रेटर, ठीक है. सो the percentage purity है ना, it indicates how much of a substance in a sample is the desired compound, right? The desired compounds being C and D, right? Not I and J. So impurities may be present. So this percentage shows the purity of a substance. It is calculated by comparing the mass of the pure substance to the total mass of the sample, right? We'll just go over an example and you guys will get what I'm talking about. So it will become much clearer when we do an example. This is the formula for percentage purity. That is mass of pure substance, and you divide it by the total mass of sample that you've obtained, and then you just multiply it by 100 to get the percentage purity. Okay, so we have a question. A sample of impure magnesium carbonate weighing 12 grams is treated, see it's impure sample, okay? It's weighing 12 grams is treated with excess of hydrochloric acid. ठीक है. अच्छा, अब जहां पर एक बात आप लोगों ने याद रखनी है, वन थिंग दैट यू गाइस शुड रिमेंबर इज, जहां पर भी एक्सेस लिखा होता है ना, वहां पर इसका मतलब ये होता है कि ऑल ऑफ दिस मैग्नीशियम कार्बोनेट हैज रिएक्टेड, यानी कि 12 ग्राम्स सारा का सारा रिएक्ट कर गया, यानी कि द हाइड्रोक्लोरिक एसिड इज सफिशिएंट टू रिएक्ट ऑल ऑफ दिस 12 grams ऑफ मैग्नीशियम कार्बोनेट. सही है. So the reaction produces 2.64 grams of carbon dioxide. Calculate the percentage purity of the magnesium carbonate sample, right? So you have 12 grams of magnesium carbonate in inverted commas, okay, quote unquote. So you don't have like a pure sample, right? This magnesium carbonate के block के अंदर ना, there are a lot of impurities. Maybe dust होगी इसके अंदर, maybe कोई और minerals होंगे, सही है, maybe कोई और इसके अंदर बीच बीच में कोई भी और minerals मिले हुए होंगे, right? So We need to calculate the percentage purity. So this is the impure sample's mass. Okay. And you know, okay, after reacting fully, it produced 2.64 grams, right? So can you use this 2.64 grams and the chemical equation to calculate the magnesium carbonate that would be required to produce this 2.64 grams, the pure calcium magnesium carbonate? Yes, you can. Okay. And we'll go over the example. The first step, as always, is to write a balanced equation, right? So magnesium carbonate reacts with 2 moles of hydrochloric acid to form MgCl2, carbon dioxide, and water. Okay. Next step is to calculate the molar masses of magnesium carbonate and carbon dioxide, right? क्योंकि हम इन दोनों को compare कर रहे हैं. हमारा, we don't really care about this MgCl2 or water. Say, so 2.64 grams of carbon dioxide produce हो रही है. ठीक है, we can use this 2.64 grams to calculate the mass of magnesium carbonate that would be required actually to produce 2.64 grams of carbon dioxide, right? So उस पे फिर हम divide कर देंगे 12 grams से, and then we'll get how much of that sample was actually magnesium carbonate, right? So we calculate the molar mass simply as Lan इसी तरह से किया है. Magnesium की mass, carbon की mass, 3 oxygen atoms की mass, that gives us 84 grams. This is the MR of carbon dioxide. That's step 2. Now you calculate the number of moles of carbon dioxide produced, right? So moles कैसे calculate करते हैं carbon dioxide के? Simply 2.64 divided by the molar mass MR of carbon dioxide, that is 44 grams. And that gives you 0.06 mole, right? Acha, Aslan, tell me what is the molar ratio of carbon dioxide and magnesium carbonate according to the balanced chemical equation?
What?
Yeah?
Can you repeat the first part?
Okay, so what is the molar ratio of carbon dioxide and magnesium carbonate? According
41
to the balanced chemical equation, the magnesium carbonate and carbon dioxide.
or 1?
Yes, ठीक है, exactly 1:1 है. So Aslan, tell me, जल्दी से आंसर करना है, ठीक है? 0.06 mole हो अगर carbon dioxide की produce, right? So how many moles of magnesium carbonate are needed to produce this carbon dioxide?
Um, 44?
No, 24 कहाँ से? देखो, I'll repeat the question again. Listen very carefully. सही है? Carbon dioxide and magnesium carbonate have a 1:1, ठीक है, ratio है, ठीक है. 1 mole of magnesium carbonate produces 1 mole of carbon dioxide, ठीक है, according to this equation, right? So if 1 mole of carbon dioxide is produced from 1 mole of magnesium carbonate, तो अगर 0.06 mole of carbon dioxide है यहाँ पर, ये, so how many moles of magnesium carbonate are required? It's 1:1.
Yes.
Yeah. So 0.06 ही चाहिए होगा ना magnesium carbonate का, right? It's 1:1. So theoretically, to produce 0.06 moles of carbon dioxide, we need 0.06 moles of magnesium carbonate क्योंकि 1:1 है. So now we know कि magnesium carbonate का 0.06 mole चाहिए था. Can we calculate the mass of magnesium carbonate using this moles? Yes or no? Yes, we can. ठीक है. So mass जो होगी वो क्या होगा? Moles equals grams, the mass divided by the molecular mass, right? You have the moles, that's 0.06, right? You just multiply the MR of carbon dioxide, that's sorry, not carbon dioxide. You multiply the MR of magnesium carbonate, that's 84 grams, and that's what you get. Okay, so you get 0.06 times 84 grams, and you get 5.04 grams. So yeah, this is the actual mass of magnesium carbonate that is needed to produce 2.64 grams or 0.06 moles of carbon dioxide, right? So let's go back to the question. उन्होंने how much mass of that magnesium carbonate were we reacting? We were reacting 12 grams. जबकि actual में कितना required है हमें? Only 5.04 grams. So can we calculate the percentage purity of this magnesium carbonate now? We'll just divide 5.04 grams by 12, and that gives us 42%. That's how you calculate the percentage purity.